Hello and welcome to the session on time, speed and distance. This is brought to you by Handa Ka Funda. Let us look at the circular race. Say a race is of lap length L, speeds that two people are running are A and B where A is greater than B. Then what will be the first time when A and B are going to meet? They will meet after a time of L by A minus B. Why so? Because the faster guy, which is A, he needs to cover one extra lap. So he needs to cover one extra lap, and what is the extra speed that he has? He has the extra speed of A minus B. So the time taken for him to overtake B for the first time will be L by A minus B. What will be the time taken for A to overtake B for the second time? That will be 2L by A minus B. Third time will be 3L by A minus B. Nth time will be NL by A minus B. Very similarly, if they are in opposite directions, then what happens? Then to cover one lap, both of them are running. A will cover some portion of it and B will cover some portion of it. So together the time they are going to take is L by A plus B, because one lap is the distance which is covered by A in the anti-clockwise direction, B in the clockwise direction. So together they will cover one full lap L. How about their first meeting at the starting point? Will it happen? Yes. It will happen at LCM of L by A and L by B. Why so? A comes back at the starting point at L by A, 2L by A, 3L by A and so on. B comes back at the starting point at L by B, 2L by B, 3L by B and so on. Suppose my lap length is, suppose A takes 10 seconds to come back and B takes 15 seconds to come back to the starting point. What happens? A is back at the starting point at t equal to 10, t equal to 20, t equal to 30 and so on. B is back at the starting point at t equal to 15, t equal to 30, t equal to 45 and so on. So at t equal to 30, both A and B are there at the starting point. Reason the first meeting at the starting point occurs at LCM of L by A and L by B. Suppose there is a third person also who is running with them. Let's call him C. And the speeds are in the ratio of given as A is to B is to C. Then when will the first meeting occur? At the starting point. I think that should be simple enough to figure out that it will be LCM of L by A, L by B and L by C. Very similar to the previous case. As A comes back at L by A, 2L by A, 3L by A and so on. B comes back at L by B, 2L by B, 3L by B and so on. And C comes back at L by C, 2L by C, 3L by B, 3L by C and so on. When will all of them be there? They will be there at the LCM of the three values. But can you tell me when will the first meeting overall will occur? That will be the LCM of L by A minus B, L by B minus C. This is when they are running in the same direction. Why so? LCM of L by A minus B in itself reflects the time when A and B are meeting. L by B minus C reflects the time when B and C are meeting. If I take the LCM of the two values, that means at that particular instant, B is meeting with A and B is meeting with C. Now B can be at only one position at one point of time. So what does that mean? That B is there with A also, B is there with C also. All three of them are together. So the first meeting for three people in the same direction will be given by L by A minus B, L by B minus C, the LCM of the two values. And it is not necessary that you need to take these two. You can very well do A minus B and A minus C also. Then AB and AC are your two pairs. A is common to both of them. You could also do AC and BC. Then C will be the person who will be common. AC will be L by A minus C and BC will be L by B minus C. You can take any two pairs that you like as per your convenience. Think about it. What will happen when three people are running in opposite direction? Will you make these plus? No, you won't. Three people can never run in an opposite direction in a circular lap. One person clockwise, one person anti-clockwise, third person in the middle. That's not going to happen, right? There is one more interesting point. We know that people running around in a circle, if let's say A and B are running around in a circle which speeds A and B, they will meet at the starting point after this much timing. But they will meet at various other points as well. How do we find that out? Let's say the ratio of these speeds is P is to Q. their speeds are 5 and 10, then it would be 1:2. Reduce it to the smallest ratio possible and you get the ratio as P is to Q. If they are running in the same direction, then they will meet at P minus Q different points in the circle, provided P is greater than Q. If Q is greater, then it will be the other way around. However, if they are running in the opposite direction, then they will meet at P plus Q different points on the circle. That wraps up the session on time, speed and distance. Please stay tuned at Handa Ka Funda to watch other videos on other chapters. Thank you.